Hey everybody, and welcome to episode 297 of the Ruby Rogues podcast. This week on our panel we have Brian Hogan.
Hey everybody.
Dave Kimura.
Hello.
Jason Swett.
Hello.
I'm Charles Max Wood from devchat.tv. This week we are going to be talking about scaling Ruby applications. I'm curious, to what extent have you guys actually scaled Ruby applications?
Well, I've played around with scaling a little bit as far as even going to an Elastic load balancer or having my own little homebrew HA proxy. I've also used Nginx for routing a single connection coming in and having that balance off to multiple web servers. So it's definitely a tricky topic, and there's a lot of moving parts in it.
Yeah, there's so much to this discussion. I mean, I've done the HA proxy thing. I've done the Nginx thing as well. I've done the unicorns and the Puma and all those different things. And lately, my experimentation time has gone to trying to scale Rails applications using Docker and Rancher for an infrastructure, using Rancher's load balancing service.
Oh, interesting.
And it becomes interesting because then you get all the fun things that come with launching Docker containers and you know it seems very simple, and then you run into some interesting issues along the way.
And for me, my scaling experience hasn't usually been like a lot of concurrency or large number of users or anything like that, because most of my work has been like back office type applications used by just like internal staff. So my scaling has been like large amounts of data used by a small number of people.
This episode is sponsored by Lob. Lob provides an API that enables developers to send postcards, letters, checks, and more as effortlessly as sending emails. Lob is trusted by over 6,000 customers, including Amazon, Square, and Council. They're kind of like SendGrid or Twilio, except for snail mail. They're providing the building blocks for people to incorporate print and mail into their application with their API, and their technology takes all the pain out of mail and can easily be integrated with any application. They have libraries available, and you can send 1 or 1 million at a time, and their web service is always available, and requests go through instantly so that your mail is more timely and relevant. You can use webhooks to follow your mail through the mail stream with live tracking events and PDF proofs. Lots of customers use Lob for marketing purposes, but they also have a lot of customers using them for transactional purposes, such as sending a HIPAA-compliant mail for insurance and healthcare companies, address verification postcards like couchsurfing, or billing notices. Go check them out right now at lob.com.
Yeah, and I've done some scaling as well, but usually what I wind up doing is optimizing the database and setting up queues for handling, what's the word I'm looking for? Asynchronous jobs and things like that, just to take workload off of the main worker threads for the web server. And then I've also done some round robin stuff on Nginx.
Do you guys have like a go-to list of priorities as far as performance stuff or scaling stuff or whatever you want to call it?
Oh, I sure do, and I gotta agree entirely with Charles. Is that I start with how can I keep my infrastructure simple?
Yep.
And what does that mean? So does that mean, okay, obviously the first step is that emails are going to be done as a scheduled job rather than right in line, right? I'm gonna set up some kind of a job that will send the emails out. I'm going to start looking into database views, and I'm going to start looking at database query optimization and things like that. And where am I pulling my data from and things like that to reduce some load? Because, the crazy thing is I've seen these situations where a lot of effort goes into setting up a more complicated structure for the Rails application, only to bottleneck at the database level. And it's like, oh, that's kind of a bunch of wasted work then. Because you still have to deal with that kind of situation. You still have to deal with making those queries optimized. And then a lot of times, the first place I start is with fragment caching with Rails. Because I can save a lot of render time and database choke point time just by doing some sort of fragment caching.
Yeah, I didn't even talk about caching, but I do that.
It's interesting, Brian, that you approach it that way, because I approach it kind of differently. Which is, let's say you have a page that's loading and it takes like 3 seconds to load, and that's too long. You want to get it down to like well under a second. A couple of the first things I would look at is like, is it making too many trips to the database?
Right.
Because usually that's the case, especially with Rails. You have a lot of like N+1 queries a lot of the time, and so you can just like eager load that stuff and then not have that issue anymore. And that like takes care of a huge portion of the cases. Is just, are you making too many trips to the database?
Yeah.
Yep, definitely.
One of the things that I always want to remind everybody who's listening is that Active Record is pretty great when it comes to managing a record. Like if you have to, get a record and modify a record, it's pretty great for that because it handles all that heavy lifting. But it's kind of rotten when it comes to building up complex SQL queries. You kind of need to know your way around the database. And so one of the things that I always recommend people do is as you're looking and developing your Rails application, just take some time to look at what the log is spitting out on the screen. Look at the queries and figure out if those are good. Don't just rely on the queries that Rails writes for you, because sometimes they're not going to be optimized for speed. They're going to be optimized for how they were programmatically put together. And you can save an awful lot of time that way. And I have taken to, in the last, I think, 3 years, I've sort of taken to doing as much as I can to bundle up data in the controller, and then try to send it all there, because it's very easy to accidentally just start having queries fire off in your views if you're not paying attention.
Yep, I would agree.
I'm kind of a mix of both. Database optimization is absolutely important, and that's where you're probably going to get a lot of your speed. But as far as the N+1 queries, I usually resort to fragment caching pretty heavily on a lot of things. So, for example, my Drift and Ruby site, it's a simple site, but it does have a lot of queries that goes on. And I think I run about at the application level, a 20 millisecond response time, just because I'm leveraging so much of the fragment caching. So a lot of the database queries just never even happen until that cache becomes stale.
Yeah, it's really interesting, right? When you think about it, like how much does your data on the screen actually change, right? It changes when the database changes. So, so many sites that I've done some rescue work on, they're always hitting the database. The data change may change once a year, but every time that you hit the page, it's doing a query. And it's something that's important to think about is, do we need to get the data from the database? What is the value of getting it from the database every single time?
Yeah, absolutely. Especially, I've run in and I've been bitten by this so many times where I had a improperly indexed cache, so it didn't expire, and I'm just like, beating myself up trying to figure out like, why is this data not updating? And then I usually look back and it's like, oh, well, that's because I have some generic cache name. I'm not actually referencing the model and the data that would be changing. So it's one of those things that you have to look out for as well, because you can start introducing your own little pain points there.
Yeah, I don't know about y'all, but when I'm doing stuff with fragment caching, I make sure it's enabled in development mode too, just to catch those kinds of things while I'm developing, because I will invariably do that all the time, and I'll say, oh, the cache isn't expiring like it's supposed to. That's not good, because I used to just kind of like ignore it and then wait till I'll wait like a couple days before deploy and then start running it in production mode to see what happens, and then realize, oh, everything's broken. So I've taken to, if I'm doing any kind of caching, I'll just start flipping the switches to have it work in development mode too.
I think it's interesting that we're talking about, we went to scaling, and I think a lot of people think, oh, well, scaling is you add more servers and all this stuff. But it seems like there are two ends to scaling, and one end of scaling is I'm going to make my machine handle more work. And that's what we're talking about here with the fragment caching and eager loading and things like that, where it has to do less work either by going to the database less frequently, or actually, in the case of caching, it just immediately returns something that's basically static content at that point. And so it can handle more requests because it doesn't have to do as much work per request overall if you average it all out. And then there's the other end of things where once you kind of max load your server, then you start doing the other kind of optimization and scaling. And yeah, I find it very interesting too that we've all kind of gone to the place where it's, well, let's see if we can make the server handle more before we actually start duplicating servers.
Well, yeah, because all of a sudden I got 3 servers to manage now, right? I got the 2 application servers, and then I got the load balancing server, right? And then I need some kind of infrastructure. What if the load balancer goes? I need some kind of infrastructure in place to deal with that. So, yeah, I'm all about trying to reduce the pain before I get to that point, right?
Three servers is 3 times the fun, right?
Right. Yeah.
But it really shouldn't be that much more difficult as you add more servers, especially with like an auto scaling group.
Mm-hmm.
You know, one of the things I've been looking at is how can I make my web servers as agnostic as possible. So it doesn't matter if I destroy one server or not, because all the traffic will just be loaded off to the other available servers. So I think it's important that as you are deploying a web application, that you're not putting specific roles or responsibilities on a single web server, that they should all be, for lack of better words, identical to each other. So as you need more traffic, you just throw on a new web server, and you can use something like Ansible or some other kind of automation IT tool to provision the server to get everything set up for you. So all you have to do is click a button or run a script, and it'll create the new instance or the VM, automatically provision it. Once it's up and running, it's loaded automatically into your load balancer pool.
Yeah, that's what I've been doing with Rancher. Just using creating hosts, creating containers, and you can create scheduling rules in Rancher that say any host that has the label app will automatically get this Docker container attached to it or applied to it. So I can use Rancher to provision a new box using Azure or DigitalOcean or Amazon, any of those in those APIs, and Rancher will provision a new box and throw the Docker engine on it. And then depending on which label I give it, or app or DB or whatever label I give it, it'll auto deploy the app's container to it and add it to the load balancing pool.
So one question that I've had, because I've done, like I said, really basic load balancing, usually using Nginx or something, and it just round robins it, which means that, you know, one server may get more loaded than the other ones. But how do you keep that from being the single point of failure? I mean, if your load balancer goes down, is your whole website down, or do you have some way of failing over when you do that?
And that's where networking gets so much more complicated, because now you're looking at high availability, where you have your one IP address for your website, it's coming in, and you have to be able to have a failover system where if the load balancer goes down for whatever reason, if it's in a particular region that's getting hit with a hard DDoS, you need another one to pick up immediately. And you know, I think that's a great topic of discussion, because that's one of the more complicated things. And I think most people don't really worry about that until they start growing into a much, much larger user base.
So should we stick with the simple stuff for now and then maybe dig into that here in a few minutes?
Like the only experience I have with that is that I have one site on DigitalOcean that's managed that way, and DigitalOcean has floating IPs, so you just kind of move the IP to a different load balancer, and that's how I handle it with that, because it was the simplest thing out there. So, but yeah, it's one of those things where that matters when your load balancer goes down. That's a really important question, because you can say, "Oh, I got a load balancer now. I'm all set," and then your load balancer's down, and you got 2 backends that are working, but that no one can get to them because the domain name is pointed at your IP for your load balancer. So, have a hot standby ready for your load balancer.
Yep.
Yeah, and having a floating IP is really good as far as not having to change your DNS records, because the propagation time could take a while, and then you have to worry about the end user's propagation or their caching of that DNS entry. And while it may start working for some people, if you start changing your DNS records, then it's going to, you know, half your other users, their ISP or someone else may have a much larger time to live on that entry, and it's just, they're not going to see that your website's back up.
Let's take a break from this episode and really quickly talk about finding a job. You know, searching for a job can feel stressful, scary, and time-consuming. Pushy recruiters try to sell you on roles you don't actually want, and the job boards make you feel like you're throwing your resume into a black hole, never to be seen again. And sometimes you go all the way through an interview process just to find out that the very end that the salary offer or company culture doesn't match what you're looking for. Well, there's a solution. Hired.com is the world's most intelligent talent matching platform for full-time and contract opportunities. They make the job search faster, focused, and stress-free instead of endlessly applying to companies and hoping for the best. Hired puts you in control of how and when you connect with compelling opportunities. And after completing one simple application, top employers apply to you. And the best part is that you get money. That's right. They pay you if you get a job through them. Listeners to this show can earn double their normal hiring bonus by signing up with the show's link. That's right. You get $2,000 instead of $1,000. So go sign up at hired.com/RubyRoguesPodcast.
Yeah. And then if you switch it back, then you've got people in limbo for whatever your time to live is. So if you switch your IP address to one thing and then back to the other, so the floating IP address makes a lot of sense to me. However, if that's bound up, say, in some Amazon AWS region that's having issues, then, is that something you can move over to another region until things kind of come back to sanity? Or I'm guessing it's not a complete foolproof setup is what I'm driving at.
No, and it's not. And this is one of those things that makes it really a little more difficult for, 10 years ago, you could say, I'm going to run my entire business with just as a developer, I'm going to bring up a Rails application. And things have in the last 10 years gotten so much more complicated that you kind of need people with a lot of networking experience now for these kinds of applications. In addition to your application development experience, you kind of need a network person that you can go to help you out with these kinds of things now. Well, you got to get really good at learning networking and top of your development stuff, right?
Yep.
Yeah, isn't that what being a full stack developer is?
I thought it meant just JavaScript and backend, right? I thought it just meant that. But I agree. I think, when you say full stack, I think it should be, you need to know your networking and you need to know your database stuff, not just the backend language and the front end language.
Yeah, I agree. I think it's become... I'm trying to decide the best way to say this, but it's become more of something that people have to really understand. It's not just anymore, okay, I'm going to build my Rails app and I'm going to slap some jQuery on the front of it and, I'll load balance things and that's it. You really have to understand now the life cycle of your application, all the way from building JavaScript to deploying your Rails app to updating your database to making sure that everything is set up so that it reacts nicely when bad things happen to it. And I know a lot of people who go out there and they're like, well, I'm a web developer. I don't need to understand operations at all. And, I argue with them some because ultimately, if you don't understand how your application gets out into the world and you don't understand what it's running on, then you don't have a good foundation for figuring out what's actually happening in production.
You're dependent on somebody else to understand those things for you. And
yep.
They will, it may seem small, but, not having, just like I was saying earlier, not having a good foundation in how databases work or the specific database you're working with works. If you don't have that, then that will impact the design decisions that you make. And it's the same thing with your web application. If you don't understand how deployment is going to work, that's going to impact the design decisions you make in your application code.
Well, and I've worked in places where the operations team was separate from the development team. Mm-hmm. And ultimately, one side or the other wound up being somewhat proficient in the other side of the conversation's expertise. Because without that, we were talking past each other, trying to solve different problems that ultimately had similar symptoms. And so by understanding, okay, from the operations side, which is something that I had done before I was a developer, and that helped in that particular instance, I could talk to them in the terms that they understood and in the terms of the concerns that they had, and we could actually start to really nail down what some of those issues were. But without that, it makes it really, like I said, really difficult for you to say, okay, well, this is what's happening in production, so therefore, this is how I'm going to approach debugging it on my development machine.
Another thing that I really like to leverage is Cloudflare's proxy. Especially for images and stuff like that, Cloudflare has been a great tool for kind of taking some of the load off of the servers. For images and stuff, Cloudflare will actually proxy those images, cache them, and then send those directly to the user instead of having to hit your application or your S3 bucket. So there's definitely some really cool things that you can do at that much earlier point to offload some of the traffic and stuff to your server.
Now, is Cloudflare proxy, is that part of AWS or is that something else?
It's its own. It's its own product.
Okay.
And Amazon has something. I think it's called CloudFront. I'm not sure. Something similar like that.
CloudFront is a CDN though, which is sort of similar, except, well, it's similar but different. In the sense that it proxies that connection and then sends the request out to a server near you. I wonder, though, a little bit, because I've talked to several people, especially in the JavaScript world, where they have some kind of front-end or full-on front-end application that doesn't have a back-end, or the back-end is something like Firebase or something like that. And so they essentially run their entire application off of the CDN. But we're talking about Ruby and Rails applications, so, Sinatra, whatever. Rack applications, that's probably a better way to put it. So if I'm hosting a rack application and I have these static assets, at what point should I be thinking about running on the CDN versus just having them in my public folder where people can hit them off of my server?
And I should point out, I guess Cloudflare is a CDN, and they have a proxy. They have a proxy front where you can actually have it store. I guess that's how it works. The Cloudflare is a CDN, and it stores the images or whatever kind of media files that you have. So any kind of asset, whether it's an image, CSS file, JavaScript, that's all going to be served off of the Cloudflare proxy. And I don't have my application send that up unless if, because I am using the asset pipeline, it does have the hash that's stored whenever I compile my assets. So that's the nice thing about a Rails application behind Cloudflare is that you're able to automatically refresh your images and your CSS and JavaScript files without having to go into Cloudflare to expire them because of the hash that's added to the assets.
So is that just part of your build process then?
It's built into Rails by default. Just whenever you precompile your assets, it creates within your public folder a assets folder, and then it creates a file for each one of your assets. So all of your CSS files will get dumped into your application CSS. And if you look at it on production, it'll actually have a hash at the end of it. And that hash is going to be for that iteration of your assets. So whenever your application gets refreshed from an end user, it'll see that it has this new asset. Cloudflare will request from the server, because it doesn't have that cached yet. It'll pull that file from your server. It'll cache it on the Cloudflare CDN, and from that point on until it expires or becomes stale, it's just going to be served off of your Cloudflare proxy.
Okay, I had imagined that you had to do some active pushing to the CDN in order to get your files up there as part of your build process, but it sounds like it works mostly automatically, which is really interesting. So just by having the assets out there, Cloudflare picks up, I don't have this yet, and then it goes and downloads it and then caches it itself.
Yeah.
So one thing that I'm kind of driving at here that we talked about a little bit on Skype before we got on this call was just the idea of premature optimization. So, if I have just a basic site that doesn't get a ton of traffic and I'm not really getting killed on my bandwidth because I have huge images in there, at what point do I start thinking about some of these things, or solving some of these problems?
I have kind of a general rule that I work from, which is this. I don't try to optimize very much of anything before an application goes to production or anything like that. My rule is that I deploy it to production, and then as it gets used, we kind of keep an eye on where the bottlenecks emerge. And where the bottlenecks are, that's where we give attention to performance issues and we fix the bottlenecks. It's kind of like there's this analogy I like, pave the cow paths, which is from architecture. They will, like, for example, when an architect is designing a college campus or building a college campus, they'll build the buildings, but they won't build any sidewalks. And then they'll just observe where people walk and where the grass gets worn down. And where the grass gets worn down, that's where they build the sidewalks. So pave the cow paths is something I keep in mind a lot when I'm dealing with that kind of stuff. Obviously, that approach is not going to work in all cases. Like if you know for a fact that you're going to be releasing something to millions of people immediately, then you have to take that into account. But for most applications, like if you're building something for a startup, like the chances are better than not that like it'll flop before anybody really even uses it anyway. So that's why I like don't try to performance optimize anything until people are actually using it.
Yeah, I really like that analogy. Although on that analogy too, I went to Ohio State, which is a huge campus, and there was definitely those odd paths that got paved. But then also often we found ourselves just walking straight through a building to cut through instead of going around. So, I think if you kind of take that, you can also have some irreversible issues if you don't take some kind of time to architect your application before you start developing it. Because once you start getting into a database that has millions of records or even billions, if you have to run a migration on that table, it's going to take a long time to run, and you could result in further downtime and some other issues.
We don't want to confuse premature optimization with applying the lessons of software architecture that we've learned over the last 40 years, right? I mean, there are certain things that you just do because it's good practice, and you've seen this play out before. And then I don't necessarily think that's always premature optimization.
So, as an example, if you know that you can avoid an N+1 query by doing some eager loading, you may as well just do it.
Yeah,
but some of these other things like setting up a load balancer or something when you're not really sure how many servers you're going to need, or in other words, you're not sure you're going to need more than just one server to handle all the traffic yet. That may be premature optimization. So setting up HA proxy and trying to make sure that Nginx knows how to balance everything out properly and things like that. That may be premature optimization.
Yeah. And setting up your replication for your data and all those additional things that go along with it, because
right.
those are the, I said before, those are the things that I've seen in production. I've seen people, they'll sit there with a huge, the 5, 6 app servers, 7, 8, 20 app servers, all load balanced, all pointing to one database server. I was like, well, now come on. That's helping some. I mean, Rails, that helps with Rails because Rails is a little memory hungry and a little bit slower than other stuff. But still, eventually you're going to have too many database connections in there. What are you going to do then? So yeah, those are the things. If you've identified through your experience that these are the things that always go wrong. I don't necessarily think that's premature optimization to address those things, those low hanging fruit things.
Here's something that is definitely like an example of premature optimization. So I started working on this application one time. I was working with a new client, and it was like the first week of working together. And they had another developer who was involved, but not very much. But this other developer gave me a couple tasks to do. One of the things he wanted me to do was take the email sending that happens like when somebody registers or takes some other action in the application, it would send them an email. And the job I was given was to put that email sending in a background process, which is generally a good practice. But I did this, and since it was a lot of like messy legacy code, it took me like a non-trivial amount of time to do it, like a few days at least. And then sometime later, I discovered that like almost nobody was using the app. And so it's like, does that really make sense to prioritize your resources that way, to like spend all your time on that little tiny, like the users probably won't even notice that. And if they do notice it, it's only like 4 people total anyway. So that's like a really specific, concrete example of something that is premature optimization.
Exactly. As part of the scaling story, one of the things that you need is data. So you need to be using whatever tool you're comfortable with to pull logs, to pull traffic logs, to pull performance logs, whatever you're using, whether it's something like New Relic or just anything like that. Know what to fix, know where your pain points are at, know what the slowest pages of your website are, know what the longest queries are that are taking. Come up with some mechanism to pull all these things together so you know where to spend that time. If you look at it and go, well, we're getting 1,000 signups an hour, that might be a situation where you want to move the thing to a background job or something. But gosh, if you're getting one sign up every 2 weeks, and it's going to take you 2-3 days to implement something in a legacy code base, it's not a good use of your time. What does the data show you? And if you're not collecting those metrics, then you will never know what normal looks like. You'll never know when you had a traffic spike because you don't know what the previous data. You want the historical data so that when you look at it, you can say, we're having some abnormal things. Things are different now. We need to react to those kinds of things.
Do you have a specific tool or tools that you like to use for this? I mean, I've used New Relic. I know that there are other tools that will watch your logs and pull the data in and parse it and give you reports. I'm curious, what systems have you guys used for this? Because, it does make a lot of sense to make it a data-driven thing where it's, hey, this request took 3 seconds, or this request took 2 minutes, which was way too long, or other things related to that where it's like, okay, I'm getting a ton of requests to this particular endpoint, so even though it's not too slow, we could optimize it and essentially reduce the amount of work the server has to do in a meaningful way. How do you measure that?
New Relic has been one of my main go-tos for checking to see where my slow points are. It's a pretty great tool. Even their free version, you can still get a lot of metrics out of it.
For the longest time, I've used Zabbix to monitor servers, because I can monitor the things that are not the app related things. I can monitor the CPU usage and memory usage, things like that, and so I can identify which of the servers and the application is having some trouble right now. Which is always an interesting story because you'll see. You have 2 identical servers provisioned identically. One of them is getting some weird memory spikes, and you can't figure out why that is. So that's always a fun thing to track down. But there are other options too. There's things like FluentD, where you can install an agent and have your logs centralized. You can have the database logs going to FluentD and being shipped off somewhere else, like Elasticsearch. And then you can use something like that to visualize your stuff. You can have your Rails application shipped off to the FluentD shipper and have it sent off to Elasticsearch, and using an Elk stack to visualize your logs and from your different parts of your application can be useful too. But I mean, that's a lot of setup that you have to do. That's a lot of extra work. So when you start looking at the price of something like New Relic, compared to your time of setting up, managing an Elk infrastructure just to monitor your apps, the price of New Relic looks really, really appealing after that.
Yep.
Yeah, it's a little bit off topic here, but I found an XKCD article. I love that site. And it's about premature optimization. And it says, are you prematurely optimizing, or are you just taking time to do things right? And then it goes down. Are you consulting a flowchart to answer this question? If yes, you're prematurely optimizing. So I think it's kind of one of those funny things, but it really rings to the truth that, if you have to really question, like, are you prematurely optimizing? Chances are you probably are. But I think, you guys have definitely made some great points about there are certain things, just that low-hanging fruit, where it is going to give you that performance improvement at minimal risk. So why not do it? But then adding in extra services, like you were saying, Jason, with the background jobs for something that someone may never notice, now you just added a level of complexity to your architecture that's going to require maintenance.
Yeah, but the flip side is sometimes that's appropriate. So, if you're getting more traffic, or you're sending a lot more emails, or you add some feature that winds up increasing your email load, now that's not premature optimization. Now it's actually going to have an impact on your server's performance. So
yeah,
what
the key is if, right? That's right. The key is when if becomes when, then it's time to double down on making it happen.
Okay, so what's that cutoff? Is it just a judgment call you have to make, or is there some method of kind of making that decision in an efficient way? So you look at it and you say, okay, this is actually going to manage that. Do you start collecting data at that point? Should you have already been collecting data to make that decision?
No, I agree. You should be collecting data all the time, and then you should be kind of building it into your plan. We're going to launch this new feature that's going to send automatic email digests to everybody. We're going to launch that new feature next month. Well, that might be the time that you start looking at how your emails get sent from the application, because you're rolling it into a new feature, and you're sort of planning for that. We expect that, given the number of users we have and the number of traffic on our site, we expect the amount of emails that get sent out to double or triple or whatever that number is, based on your user base. Things that you kind of plan that in. So that's the case where I'd say, well, and as a side benefit, I guess our registration emails will also use this background job system because we've got it now.
So should you build that in based on what you forecast, or should you wait until New Relic tells you have a problem?
Like I said, I guess if it's part of if you're rolling out a new feature, it might be worth your time to do that. I mean, you could always be reactive. The thing I always worry about with things is what is the impact that the people visiting your site experience. If you want them to experience a brand new feature of your site, you probably want it to be fast, right? You don't want long rendering times. You don't want them to be waiting for that send up while you in process send out a large email, stuff like that. So you don't always want to wait for your visitors to tell you there's something wrong. You want to kind of get ahead of that whenever you can. And that's why I think having that historical data and looking at it and analyzing it will kind of let you know, like, hey, in the last week, I noticed that our traffic is increasing very slightly, but that means also our CPU usage is increasing. We probably should get a handle on that before people start complaining.
Yeah, makes sense. And that's kind of where I come down to it's definitely a judgment call you can make. But, for some of the larger decisions that you may wind up making, yeah, you're going to want data to back that up so you're working on the right things. But yeah, it totally makes sense. If you see that increase and you see that it's going to impact users in a negative way, and you can kind of intuit it, then yeah, go ahead and make the optimization now.
I guess I'd be really careful. This is sort of developer experience and intuition that you get. You feel like this isn't going to be premature optimization. You feel this is a good idea, and I have always seen a lot of time wasted when a developer and when an engineer feels that it's a good use of their time, and they haven't looked at the data, because it almost always seems to be a bit of premature optimization and wasted time. Not always, but I guess I'd rather have someone have a discussion about actual data and numbers than a gut feeling about something going to be slow.
That's an interesting point, because, especially when you're early on in a development process of a new application, you don't have those kind of metrics. So it's one of those gambles where, do you push it live first to see, to start gathering some of those metrics? Or what kind of tool do you use to do a simulated load test to see where your pain points could be?
Oh, yeah. I've done those. I've done things like Siege and stuff to pound the hell out of a site before, just to get some idea. But then, really getting something in front of people as soon as possible is the best way to go. And I think sometimes we're afraid of that. We're a little bit afraid to show what we're doing until we get it just perfect. But there's a lot of benefit, especially in terms of getting some ideas about how it'll be used and how it performs. Just getting it in front of people as early as possible, even if it isn't done. Getting that one thing out in front of people, and start so you can collect that data and make sure your data collection infrastructure is in place too, right? So the earlier you can get some numbers about something, the better off you'll be.
Yeah, I'll also admit that I've done what I'll call immature optimization. And what that is when I really, really want to try something out. And so I build it in, and then I justify it by saying that it's going to make the website better. You have to be careful of that too, because I think we all get to that, okay, well, I'm doing the same thing over and over again, and it's, I really want to try this new thing. And there are appropriate ways to do that, but building it into the application without understanding what the repercussions are is probably not the best way to do that.
I like that term, immature optimization. I like that a lot.
All right, so are there any other aspects of scaling or performance tuning that we should talk about before we move on?
This episode is sponsored by Compose.io. Databases are arguably the most difficult part of the stack to manage. The last thing you want is to wake up at 4 a.m. because the database failed and you have no backups. Compose has all that covered for you, so rest assured that your database is fast, reliable, and always on. It's production-ready cloud databases on AWS and GCP for SoftLayer, so go check them out. You can pick from 9 databases including MongoDB, Elasticsearch, Redis, RethinkDB, MySQL, and one of the latest, ScyllaDB, which is a fast drop-in replacement for Cassandra. All databases come with guaranteed RAM, IOPs, and CPU that auto-scale, automatic daily and on-demand backups, high availability nodes, security you can count on with private VLAN, IP whitelisting, SSH and SSL, two-factor authentication, and much more. Deploy your database in minutes and they'll take care of all of the administrative tasks like patches and upgrades. Set up is fast and easy, so go try them out for 30 days free at compose.com/devchat.
All right, well, let's go ahead and do some picks then. Brian, do you want to start us off with picks?
Sure. I only have one pick this week because it's the first thing it's top of mind for me. I have been studying for my amateur radio license, and I just got my license over the weekend. And so if anyone's interested in getting involved in that, I highly recommend hamstudy.org because you can do the practice tests. But also ham. But one of the nicest things about the site is that on the question cards, when you look at the correct answer, that you can actually flip the virtual study card over, and there's a licensed ham who's written an explanation as to why the answer is correct and why the other answers are wrong. And I thought it was a really nice community-driven thing, just to see not just the questions, but here's why. And then a reference back to the AARL handbook. So, really cool stuff.
I need to renew my license. It's cool stuff. I recommend it. It's kind of a fun hobby, just both from the technology standpoint and from the social. I'm going to talk to somebody in another part of the country or world.
Exactly.
I really didn't have a pick for this week, but your pick, Brian, reminds me of a book that was released. I think it was in 1966, called Bobby Fischer Teaches Chess. And if you're not a chess player or anything, it's a book that has a bunch of illustrations of a chess scenario, and you have to pick the right move in order to, the best possible move. So it's a lot like that ham radio thing where you have to make your decision, and then it's either the right decision or wrong decision. It explains why. But it's a book that I read as a kid, and I really wish I could find that book around. I'm sure I can find it on Amazon or something. But it's a really cool book. And I think that if we were to look at from a development standpoint, a lot of things in that scenario, like, here's my situation, here's my issue. What is the best way to what's our best move here? And, there's going to be a better answer, a right answer, or a wrong answer. And I think that's something that we should all keep in the back of our head. So that's my pick for the week.
Very cool. Jason, what are your picks?
Since Brian was talking about ham, although not the edible kind of ham, but that's what I thought of. My pick is going to be food related. There's this guy named Jack Pepin. Have you guys ever heard of him by chance?
Oh, yeah.
Yeah, he's awesome.
Watch him on PBS all the time.
Yeah, that's how I found out about him. We lived in a place a few years ago that didn't really get many TV channels, and so I watch PBS like exclusively. And I saw him on there, and since then I've really grown to like him a lot. I have a couple of his books, and you can find videos of his on YouTube. And I think he appeals to my geekiness in a certain way, because he describes, like, he shows you not only what to do, but explains why he's doing it, which I really appreciate, because you see a lot of cooking shows where they tell you to do such and such thing, or in a cookbook they tell you to do this or that, but they don't explain why the heck you're supposed to do that. But he does, which I really appreciate. So it's Jack Pepin. It's JACQ. Well, I guess this will be in the show notes if you really care, but it's JACQUESPEPIN, Jack Pepin.
All right. I'm going to jump in with a couple of picks. You may notice a slight increase in audio quality when I talk on the podcast. I figured out over the last few weeks that my microphone had died a terrible death. And so the podcast editors have been, they've basically been fixing the audio quality by gaining or increasing the volume, which also raises the noise floor when I talk. And so anyway, I actually went out and got a new microphone, and I love it. It's the RE20 by Electro Voice. Anyway, I think it sounds really, really great. They also have a kit that you can buy, and so I actually got the kit. So I have a new boom arm and shock mount for the microphone. And the shock mount is the part that you mount the microphone into that has the elastics that isolate it from the rest of the desk. So if my kids come in here and bump my desk while I'm talking, or if I'm moving around, or making wild gestures while I talk, if I bump the boom arm or bump the desk, then it makes it so that you don't actually hear this big boom into the microphone. So anyway, I really am happy with the microphone and with everything else that I've kind of gotten to fix and figure things out. I also switched back to my old mixer when I did it. I originally got a mixer with like 16 channels on it because I thought I was going to get a stack of Mac Minis and then be able to, adjust everybody's volume and stuff and make everybody sound terrific through that system, but I never got around to it. And so I just moved back to my Xenix 802 mixer, and I'll put a link to that in the show notes as well. But it's really simple. It has a bunch of little knobs in it, and so I only ever use 2 channels on this thing. And so, why have this giant mixer taking up space? The other thing is that I figured out that the mixer itself had developed some issues and was generating noise as well. So I'm back to a simpler setup, and I'm super happy with it. So anyway, as far as podcasting goes, that's pretty much that. And finally, I just want to point out on the podcast, some people may have noticed that there was a 2-week gap between episodes, I think 292 and 293. And the reason that there was a gap is because onboarding a new podcast editor took a little bit of time. So if you missed us and now we're back with 3 or 4 episodes, just note that I'm apologizing on the first episode after that time period, but we are getting the episodes out. So, well, as you can probably tell because you downloaded this one. But anyway, I thought I'd point that out and tell people I'm sorry if you missed us for 2 weeks. But anyway, we'll go ahead and wrap this show up. Thank you all for coming, and we'll catch you all next week.
Bye, guys.
Bye, everybody.
Bye.